Please be seated. Welcome, everyone, to Thayer School's 2012 Investiture Ceremony. I'm Joe Helbley, and I'm the Dean of the Thayer School of Engineering, and it's my pleasure to preside over these ceremonies. At commencement exercises tomorrow, the Thayer School of Engineering will award 143 degrees. This includes 75 Bachelor of Engineering degrees, which I will point out to our graduates is the second largest BE class in the school's history. 18 of these will be AB, BE degrees earned jointly, 47 Master of Engineering Management degrees, 7 Master of Science degrees, and 14 doctorate degrees, also the second highest total in the school's history. In addition, Dartmouth will award AB degrees to 78 engineering sciences majors. Today we will confer hoods on our BE, MEM, and MS candidates and caps on our doctoral candidates. The hoods are edged in orange because in academic regalia, orange denotes the discipline of engineering. It's my pleasure before we begin to introduce our distinguished group of visitors and faculty on the platform. On my immediate left, we have Dr. Robert Metcalf, the Professor of Innovation and the Murchison Fellow of Free Enterprise in the Cockrell School of Engineering at the University of Texas at Austin, and our speaker today. Seated next to him is Dr. Carol Folt, the Provost of Dartmouth and the soon-to-be interim President of Dartmouth College. Mr. Terry McGuire, Thayer Class of 1982, Chairman of the Thayer School Board of Overseers, and co-founder and managing general partner of Polaris Venture Partners. Mr. Randall Lunn, Dartmouth Class of 1973, Thayer Class of 1975, member of the Thayer School Board of Overseers, and founding partner of Palomar Ventures. Mr. R. William Burgess, Dartmouth Class of 1981, member of the Dartmouth College Board of Trustees, and managing general partner, ABS Ventures. Dr. Marianne Fox, Dartmouth PhD, Chemistry 1974, member of the Dartmouth College Board of Trustees, and the Chancellor of the University of California at San Diego. And Mr. John Replogle, Dartmouth Class of 1988, member of the Dartmouth College Board of Trustees, and CEO and President of Seventh Generation. On my immediate right, Dr. Ian Baker, Senior Associate Dean for Academic Affairs and the Sherman Fairchild Professor of Engineering. Dr. Alex Hartov, Thayer Classes of 1988 and 1991, and Director of the MS and PhD programs and Professor of Engineering. Dr. Robert Graves, Co-Director of the MEM program and the John H. Crabiel Senior Professor for Emerging Technologies, and Dr. Erland Schulzen, Chair of the Engineering Sciences Department and the George Austin Colligan Distinguished Professor of Engineering. I'd also like to recognize our Faculty Marshal, Dr. William Lotko, Professor of Engineering, and our Student Marshals, Alden Adolph, Dartmouth Class of 2011, Thayer BE 2012, and Allison McKendry, Thayer MEM 2012. It's my pleasure to welcome this distinguished group here today and to welcome each of you, parents, husbands, wives, brothers, sisters, other family and friends who've played a critical role in helping our graduates reach this milestone today. It's now my pleasure to introduce Dr. Carol Folt, our first speaker this morning. Provost Folt serves as Dartmouth's Chief Academic Officer. She is also the inaugural holder of the Endowed Faculty Chair named the Dartmouth Professor of Biological Sciences. Dr. Folt is a leading researcher in metal toxicity and the effects of dietary mercury and arsenic on human health. In 1991, she received the Dartmouth Huntington Prize for Excellence in Teaching and Research, and in 2010, she was elected a Fellow of the American Association for the Advancement of Sciences in recognition of her work in environmental science and in higher education. I am pleased to introduce Provost Carol Folt.
Hello, everyone. The Thayer School is an excellent example of what I think is distinctively Dartmouth. It's a place where people matter. It's a place where students are at the center. And it's a place where our faculty blend serious, cutting-edge research seamlessly with a deep commitment to students as individual learners. Just walk along the second floor of Cummings and admire that amazing wall of patents. That wall demonstrates so well the cross-disciplinary impact, the innovation, the curiosity, the passion of Thayer students and faculty. Engineering as a discipline and engineers as participants in the life of Dartmouth also extends way beyond Thayer School. Why? Well, first, because as students, you spend your time learning not only in Thayer, but across the spectrum of disciplines, courses, participating in so many different activities. And in doing so, you are introducing your friends and your classmates to your perspectives as an engineer and as a person in all of those settings. Second, our Thayer faculty also teach and engage with students across a wide variety of majors. I love the fact that over 50% of Dartmouth undergraduates take classes at Thayer. And third, the students, the faculty, and the staff of Thayer are partners with people from across the institution, and they do this to achieve a number of variety of initiatives to address a realm of different problems, and they have been doing that for years. The Thayer faculty this reach of the Thayer faculty has become particularly obvious to me in the last year because I've seen how important Thayer faculty members are and the prominent roles that they've been playing in our institution-wide strategic planning process as we try to look at Dartmouth for the next 250 years. The success of these collaborative interactions that you as engineers have with each other and with people outside your field will be critical for creating a sustainable and global future. Not only is there already a critical need for more engineers, the necessity for people who can bridge the thinking of engineering with other emerging fields are only going to increase. For example, just last year, activities at Thayer show this wonderful ability to bridge. Some of you participated in the $300 house project led by Tech Professor Vijay Govindarajan to design affordable housing in regions of greatest poverty. Some of you designed and founded the chapter of Design for America, and you took on incredible projects such as improving employment for veterans, reintegrating into civilian life, and dental health for pregnant women. Some of you created and tested a prototype biomedical device designed ultimately to assist Alzheimer's sufferers. And one of you even performed on stage, national TV, as a member of the Heirs on NBC's Sing-Off. So we have to congratulate students, faculty, and staff on this wonderful day. You have created together a very special place. And I really think that as a result of those joint efforts, you have also acquired skills and habits that will enable you to be very successful in the future, working across disciplines, working on pressing issues, and opening new frontiers. So we want to say, please stay connected to Hanover, to Thayer, and to Dartmouth. Your presence, your ideas will always be welcome here. Thank you, and good luck.
Thank you, Provost Folt. We would now like to recognize the recipients of the 2012 Thayer School of Engineering Awards. Now, recipients, when your name is called, please come to the stage using the stairs on my right and remain on stage while I read the citation accompanying your award. The first award is the Dartmouth Society of Engineering Prize, awarded annually for outstanding performance in an engineering project by a Bachelor of Engineering student or students. This year's Dartmouth Society of Engineers Prize goes to Connor Galligan, class of 11, Merritt Jenkins, class of 2010, and Eric Packer, class of 2012, for their engine's 8990 project, Water Recovery from Diesel Generator Emissions. This team of students devised a method for capturing and condensing water vapor from the exhaust stream of diesel generators and filtering the water to make it potable. This system could potentially serve as a source of drinking water for military troops in the field, reducing the need for water delivery via convoy, saving the military millions of dollars each year, and improving the safety of the men and women serving our country. It also has significant dual-use possibilities for remote regions of the world. Congratulations, gentlemen, on your award. The Charles F. and Ruth D. Goodrich Prize is awarded annually in recognition of outstanding achievement with special emphasis on academic achievement. This year's prize goes to Master of Science candidate Dermot McHugh, Dartmouth 09, Thayer 11, Thayer 12. Dermot? In addition to excelling in all of his courses throughout his many degree programs at Dartmouth, Dermot completed a detailed finite element analysis of the causes of unexpected early failure of one of the most popular hip replacement technologies, a study that becomes of increasing interest to the members of our faculty year by year. Congratulations, Dermot. Nicely done. Our next award is the Thayer School of Engineering Corporate Collaboration Council Engineering Management Prize. This prize is awarded for outstanding performance in the Engineering 390 internship and project experience by a candidate in the Masters of Engineering Management program. This year's prize goes to Arjun Thampan Subramanian for his work on marine fuel oil procurement and price risk management strategies for Heidmar, a company that operates commercial tankers worldwide. Arjun? In a brief but undoubtedly intense 3-month period, Arjun developed, tested, and validated strategies that balance purchases of oil through the immediate spot market and through futures contracts. Outstanding in his thoroughness and his creativity and problem solving, Arjun served as an outstanding representative of Thayer School's MEM program. Congratulations, Arjun. Our next award is the Thayer School Faculty Award for Academic Excellence. This award recognizes the student who has obtained the highest academic record in coursework required for the Bachelor of Engineering degree. This year's award goes to Lucas Hussey, Thayer, class of 11, whose GPA, sorry Luke, I'm going to read this out loud, is an impressive 3.93. Luke? Luke is an outstanding scholar-athlete who achieved this year's highest BE GPA even while spending significant time, as his classmates know, on the gridiron as a linebacker on Dartmouth's varsity football team throughout his entire stay here at Dartmouth. Congratulations, Lucas, on an outstanding academic record. Our next award is the Thayer School Dean's Service Award. This award, established 6 years ago, recognizes the student who has made exceptional contributions to Thayer School, Dartmouth College, or the broader world. The recipient is selected from nominations made by members of the Thayer School community, including faculty, students, and staff. This year's award goes to PhD student Jennifer Lynn Demers. Jen? In addition to being incredibly busy with her research project, Jennifer Lynn manages to aid and support the Thayer community in a variety of ways, including serving as co-president of the Dartmouth Society of Engineers, co-president of the Thayer Council, the student leadership organization, and as a member of the Thayer Student Philanthropy Council. For this and all else that you have done and continue to do for the Thayer School community, thank you. Congratulations. The John C. Woodhouse Engineering Design Prize is awarded annually to a Thayer School student or student team who have shown innovation and ingenuity in developing inexpensive yet effective experimental research equipment. This year's prize goes to David McClatchy, Stephanie Wolf, class of 2012, and Master of Science student Jay Vincelli. Jay, Stephanie? Together, and recognize that this is for a class project and not a master's thesis, together they developed a miniaturized cardiopulmonary bypass circuit as their project for their Engineering 57-169 class, Intermediate Biomedical Engineering, a project that I learned just this week will be continuing in its development, potentially moving into animal studies over the course of the next year. So congratulations on an outstanding piece of work. The John C. Woodhouse Environmental Engineering Prize is awarded annually to a Thayer School student who, in a given academic year, has done the best work in the field of environmental study or research. This year's prize goes to 4 BE candidates: Molly Greer, Ariana Heiderer, Kevin McGregor, and Jian Wong, all of whom received their AB degrees in 2011 and are BE candidates today. For their Engines 8990 engineering design project this year, they worked on the development of a hydrokinetic turbine diffuser optimization routine for their sponsor, Concepts NREC. The team created physical and computational test methods for turbine diffusers at a 1/36 scale to measure power output. Building and analyzing 27 different diffuser shapes over the course of the project, their optimum solution eventually added a flange around the outlet to provide the highest power output increase and material efficiency, and thus deliver the lowest energy costs. Congratulations on an outstanding piece of design work. The Caroline Henderson Prize is awarded annually to an outstanding MEM degree candidate in recognition of academic achievement and service. This year's prize goes to one of our student marshals, Allison J. McKendry. Allison? In addition to being in the top decile of her class, Allison has served the MEM program in numerous ways, including volunteering in webinars, interviewing prospective students, giving tours to prospective students. She served as president of the Master of Engineering Management Council, initiated student programs to enhance cross-cultural interaction among our internationally distributed student body, went on student recruiting trips, and offered significant and concrete suggestions to help us improve the quality of the program and the student experience. Congratulations, Allison, and thank you. The Special Faculty Award for Engineering and Service to Humanity is a faculty award awarded annually to recognize a student or student team in any degree program for exemplary achievement related to the application of engineering in service to society in the spirit of our founder, Sylvanus Thayer. This year's award goes to BE candidates Elizabeth Chang, Amanda Christian, and Christopher Ng, all of whom are BE candidates in our dual degree program. For their senior capstone design project, these students developed an expandable hydrogel sphere for orbital implementation as their 8990 engineering design project sponsored by Auralab and the Aravind Eye Clinic in India. Tackling the physical, chemical, and biological problem of developing a new biomaterial that would expand harmlessly in the eye socket of children born without an eye and thus spare them painful monthly surgeries as infants. Elizabeth, Amanda, and Christopher produced a cross-linked polymer that meets all the specifications, is inexpensive, and is biologically compatible. They were so successful that during spring break just a few months ago, they traveled with their advisor, Professor Doug Van Sitters, to India to present their work to their sponsor, learn more about how their device will be implemented to help real patients, and to begin the process of carrying the work forward. Congratulations on an outstanding piece of work. The Brianna S. Weinstein Engineering Design Prize is presented to a student or team at the Thayer School who have demonstrated outstanding design skill in developing or creating new technologies, systems, or adaptive devices to address the needs and challenges of people, particularly children, with physical or developmental disabilities. This year's prize goes to Laura Coyle, Dartmouth class of 2012. And Laura is, in fact, one of those many Dartmouth students that Provost Falk mentioned earlier who, despite not majoring in engineering, choose to take an engineering class to get the design experience as part of their undergraduate studies. Laura conducted an independent project for Engines 15 undergraduate investigations in engineering and designed an affordable tandem exercise equipment device for lower body rehabilitation. Her long, diligent work resulted in a smoothly operating pedaling system that permits a handicapped or disabled peddler to work out with another person to build strength and function in the lower limbs and to also build the social interaction that comes from exercising with another individual. Laura has applied for patent protection and has started to think about potentially raising SBIR funding to further develop this concept. Congratulations, Laura. Our next award is a faculty award. Every year we recognize an outstanding member of the Thayer School of Engineering faculty for their contributions in the classroom, in the design labs, in the project labs, in teaching and mentoring our students. And I am very pleased to announce that the 2012 Excellence in Teaching Award goes to Associate Professor of Engineering, Vicki May. Professor May's research interests center on engineering education, including inquiry-based and student-centered learning. As an example of her approach, last year her Engine 71 structural engineering class built a wheelchair-accessible treehouse in Hanover's Oak Hill recreation area. And what, for me, was particularly interesting and challenging with this project is rather than having students working on parallel components, parallel projects, the entire class was an integrated team where groups of students worked on one piece that fed into the next piece of the construction that the next team of students needed to undertake, and so on and so forth. So the entire class of students conceived of, designed, built, and implemented this treehouse, which I'm confident is still standing a year later. Good. Right. In addition, this academic year, Professor May has been a consultant with Tuck Professor Vijay Govindararajan on the $300 house project that Provost Folk mentioned earlier, an initiative to design and build affordable housing for communities affected by natural disasters, poverty, or both. In addition to this structural engineering class, Professor May teaches one of our core undergraduate courses in solid mechanics, an advanced class in solid mechanics, and co-teaches Engines 2, a course for non-majors that she developed with architect Jack Wilson on integrated design. Students laud her attention to detail, knowledge of the material, level of organization, approachability, and enthusiasm. And as one student put it, her ability to really understand the question that a student is asking. Professor May, who earned her doctorate in civil engineering at Stanford and specialized in earthquake engineering, is also a registered professional engineer in both California and New Hampshire. And I should also note, before I let Professor May leave the stage, that immediately after Investiture, she will be heading to the BEMA, where she will be recognized by Dartmouth's senior graduating class at Class Day as the recipient of Dartmouth's Distinguished Teaching Award for this year. And though I haven't had time to check the record books, I'm fairly confident that that's the first time that this has happened. Certainly the first time it's happened twice on the same day. So Professor Vicki May, thank you for your thoughtful and creative work with students and for all that you do for the Thayer School of Engineering and for Dartmouth College. Congratulations. We also recognize an outstanding member of the staff with a service award for staff each year. And this year's recipient is Mr. Ross Gortner, the Associate Director of the Master of Engineering Management Program. Ross? Ross earned his BE and MEM degrees at the Thayer School and went on to work for Charles River Associates in the Resource Systems Group before returning to Thayer School almost 5 years ago to work with Professors Bob Graves and Ken Baker on administration of the MEM program. Ross contributes to every aspect, and I mean every aspect of the program, from recruiting new students to assisting current students in their search for internships and jobs, to recruiting experts for course review panels, to developing programming for alumni. This year, Ross increased his recruitment visits by nearly 50% over the previous year and also introduced a new interview by Skype model for prospective students, which resulted in a much better match between student interest and program opportunity and resulted in a significant increase in yield, a yield that nearly rivals the Tuck School's yield. That's the goal for the fall 2012 incoming class. Ross, I am very pleased to recognize you as the recipient of the 2012 Outstanding Service Award for Staff. Thank you and congratulations. It's now my pleasure to introduce our distinguished guest and investiture speaker, Dr. Robert Metcalf. Each year, the Thayer School recognizes a graduate or friend of the school with the Robert Fletcher Award, which is given in recognition of distinguished achievement and service in the highest tradition of the school. This is the highest honor conveyed by the Thayer School of Engineering faculty and staff. When Robert Fletcher was selected by General Sylvanus Thayer and Dartmouth President Asa Dodge Smith to become Thayer School's first dean and professor in 1870, He was a 23-year-old Army lieutenant serving as an assistant professor of mathematics at the U.S. Military Academy. Over the ensuing 65 years of service to Thayer School, a record that I fear may not be broken, and the neighboring community, Fletcher was to leave a strong, lasting impression on generation after generation of students. His accomplishments as director and teacher almost invariably merged in the minds of students with his quality as a human being. As Sylvanus Thayer was recognized as the father of the U.S. Military Academy at West Point, so was Robert Fletcher recognized as the father of the Thayer School of Engineering. And to our graduates, if you have ever taken the time to look at the pictures of the graduating classes from the early years of Thayer School that adorn the hallways in Cummings Hall, you can see a progression of Professor Fletcher, Dean Fletcher's contributions and membership on the faculty over this incredible 65-year period of service as the school grew from just a few students and a single faculty member, Dean Fletcher, to the vibrant institution it has become. In addition to leading the engineering school, Fletcher designed and supervised construction of bridges across the Connecticut and White Rivers, waterworks for the towns of Hanover and Enfield, and served for more than 40 years as president and engineer of the Hanover Water Company. His many activities contributed not just only to the prestige of the school, but to the betterment of the community and the advancement of engineering education. The individual selected to receive Thayer School's Robert Fletcher Award must possess the qualities exemplified in the life and the work of this remarkable individual. Today, we are honored to present the Robert Fletcher Award to Dr. Robert M. Metcalf, Professor of Innovation in the Cockrell School of Engineering at the University of Texas and the Fellow of the Clint Murchison Senior Chair of Free Enterprise and a Professor of Electrical and Computer Engineering. The Academy, however, is only the most recent career path undertaken by this extraordinary and immensely energetic individual who pursued at least 4 careers, each of which would have been significant in its own right in technology innovation before joining the UT Austin faculty last year. As an engineer scientist in the 1970s, Dr. Metcalf helped pioneer technology leading to the Internet. And in 1973, at the Xerox Palo Alto Research Center, he was one of the inventors of Ethernet, the local area networking standard on which he shares 4 patents. Between 1979 and 1990, Dr. Metcalf pursued a career as an entrepreneur and executive, where he founded and grew 3Com Corporation, persuading Digital Equipment Corporation, Intel, and Xerox to work together to promote Ethernet as a standard. By the end of the 1980s, Ethernet was clearly the dominant network technology, and 3Com the major player in this area. After stepping down as CEO of 3Com in 1990, Dr. Metcalf launched the next extraordinary chapter of his career as a publisher and technology journalist. For most of the next decade, he wrote extensively on technology and on engineering, serving from 1992 to 1995 as CEO of InfoWorld, a publishing company, then focusing his writing and for many years publishing a weekly InfoWorld column, From the Ether. Some of these columns were collected into the book Internet Collapses, published in 2000. In 2001, his career took another turn when he joined Polaris Venture Partners as a venture partner in their Waltham, Massachusetts office, helping to nurture many successful companies along the road to technology development and commercial success. And finally, or perhaps it's better to say more recently, Dr. Metcalf joined the faculty of the University of Texas at Austin, where he recently launched a new course called One Semester Startup, an interdisciplinary entrepreneurship practicum for teams of students focused on starting companies. Over his 40-year career as an inventor, entrepreneur, executive, journalist, publisher, venture capitalist, and professor, Dr. Metcalf has acquired many, many awards and honors. These include the Bell Medal and the Medal of Honor from the Institute of Electrical and Electronics Engineers, IEEE. In 1995, election to the American Academy of Arts and Sciences. In 1997, election to the National Academy of Engineering, the highest award and honor that the engineering profession recognizes. He received the Marconi Prize in 2003, the National Medal of Technology in 2005, and was inducted into the National Inventors Hall of Fame in 2007. Dr. Metcalf holds 2 bachelor's degrees from the Massachusetts Institute of Technology. He is a life member of the MIT Board of Trustees and holds master's and PhD degrees from Harvard University. Dr. Robert M. Metcalf, today it is my distinct pleasure and honor to present you with Thayer School's highest honor, the Robert Fletcher Award, in recognition of this 4-decade career of distinguished achievement as an engineer, an innovator, an entrepreneur, and an educator. Thank you and congratulations.
Thank you very much. I want you all to know that I've noticed that I'm the only one here wearing a hat. And I hope you'll allow me to continue wearing the hat while we figure out, in this case, whether you are the innovators or I am the innovator. And it's indeed an honor and pleasure to be at Thayer for this great occasion. Please, if there are any engineers here today, I hope that at the count of 3, you will join me in raising both your hands in the air and saying, engineers. So, okay, let's do that. 1, 2, 3. Engineers. Yes. So I'm an engineer, and I'm extremely proud of it. And there's no need to tell the other investitures that are going on here today, and please don't bring it up tomorrow during commencement, but engineers make the world go round. And we, through technological innovation, we are the ones who energize the virtuous cycle of freedom and prosperity. Hooray for us. And now it's time to commence. Now, so speaking of commencements, I want you to know I love commencements. In fact, I'm going to 4 of them this spring. And the reason is simple. We get what we celebrate. And celebrating the graduation of engineers is something we need to be doing more of, and I'm enthusiastic about being part of it. So now, before getting to the meat of my remarks today, I'd like to run through a list of the wisdoms often shared at commencements because they bear repeating. And I will include the secret of happiness in this list. So commencements are great occasions. They're like weddings and funerals. And they're like weddings and funerals in that they are rarely for the benefit of the putative guests of honor. For example, weddings, as you well know, Robin's here, we were married 32 years ago. We realize that weddings are not for the bride and groom, they're principally for the mother of the bride. We also know that funerals are certainly not for the benefit of the deceased. And commencements are mostly not about the graduates. In fact, they're about the people who got you here, your loved ones, the ones who sacrificed and put up with you all these years, and you cannot thank them enough. And you must never stop trying. So join me in a round of applause. And being Dartmouth graduates soon, you already know that to be good at something, especially something like engineering, which requires sustained effort and skill, you know that in order to be excellent, it must be fun. Because if it's not fun, you can't sustain your interest and excellence. So excellence must be fun. And now while you're doing that, I urge you, eat healthy, exercise regularly, get your sleep, use sunscreen, floss only the teeth you want to keep, and stay in school. That's odd advice at commencement. Now, to end these wisdoms, I'd now like to insert the secret of happiness, which was famously noted by Charles Kingsley in the 19th century and was painstakingly reconfirmed by me during the 20th century. And here it is. I'm going to save you a lot of trouble. All we need to make us really happy is something to be enthusiastic about. So what am I enthusiastic about? A lot of things, but in particular engineering. If you find life boring, you are not paying attention. If you insist on being a cynical smarty pants, go ahead, but cynics are often right. They never get anything done, and I can assure you they're not happy. So I urge enthusiasm and optimism, and in particular about engineering. Now it will make me happy over the next 2 hours of my talk to go over some of the ways, in fact, more than 14 of the ways you can have fun in your enthusiastic engineering careers over the next 50 years. During 2007, the National Academy of Engineering assembled 18 genius engineers for the purpose of developing what was called the Engineering Grand Challenges, 14 of them. I don't know why 18 geniuses came up with only 14 grand challenges. Maybe they had an attendance problem toward the end. You can find out as much as you want about all these challenges, where else but on the internet at engineeringchallenges.org. But let me give you 10 minutes worth of these 14 challenges to be enthusiastic about. And at the end, I'm going to add a 15th challenge, which the National Academy of Engineering did not include, and you can think of others, I bet. And as a bonus, I'm going to make a prediction. I'm going to predict what the next, iPod, iPhone, iPad, what's the next I thing? And I'm going to tell you a little later as part of this. So here we go. Engineering challenge, grand challenge, number 1. Engineering the tools of discovery. This is the National Academy of Engineering telling the National Science Foundation that the division between science and engineering is not as stark as the silos of our universities would suggest. Nobel Prizes often go to scientists with early access to the latest discovery tools, which were, of course, cobbled together by mere engineers. And many of the best scientists are sometimes engineers of their own tools. And sometimes, vice versa, engineers need to discover their own new knowledge in order to solve the problems at hand. That is, the distinction between science and engineering is overplayed. Number 2, grand challenges. 2 and 3, energy, particularly solar and fusion. So we need to solve energy. We want abundant, squanderably abundant, cheap and clean energy. The NAE suggests solar and fusion. So my picture is that Earth is a natural fission reactor whose thermalized radioactive decay has for 5 billion years kept our planet from becoming a permanent snowball. So we can harvest that energy, and the way we do is often called geothermal. Or we can build our own artificial fission reactors. We have 104 of them here in the United States in order to produce cheap and clean and reliable energy. So it'll be interesting to see what you all do in getting us cleaner, cheaper, non-proliferating, smaller fission reactors, or you may punt fission altogether and go on to, say, fusion. Fusion energy is more promising by a factor of 1 million, but it's also more difficult. I'd like to point out that every day a fusion reactor flies across the sky, taunting physicists everywhere. We harvest that energy, transmitted, radiated fusion energy, of course, through various forms of what we call solar energy. And it appears that in this decade, we're going to make solar energies, in particular through photovoltaics, cheaper than coal. This very decade, it looks, and you're probably going to finish the job for us. Grand challenges number 4 and 5 are 2 elements, carbon and nitrogen. I'm not a chemist, but we seem to be putting too much carbon into the Earth's atmosphere and taking too much nitrogen out. And the NAE thinks what we need to do is expensively sequester CO2. My suggestion is that we learn to profitably harvest CO2, and I leave it to you. Number 6 is water. Millions of us die each year because of a lack of potable water. We need to learn how to purify and desalinate and distribute water. Abundant energy would help with that. We do have the oceans blue. 71% of the Earth's surface is covered by water to an average depth of 12,000 feet. So there's lots of water out there. I think there's hope we can solve water. Challenge number 7 is urban infrastructure. Humans are flocking to cities by the billions. Among our urgent needs in urban technology have to do with the food chain and sustaining it as we urbanize, and also for transportation. Let's take transportation. 1 million people die every year in car accidents. Would somebody from Thayer please engineer electric cars that drive themselves? I am sick and tired of buying cars, and I don't like waiting online at the Department of Motor Vehicles for my license. Or to put it another way, when I need a car, there should be an app for that. Number 8, medicines. Just as physics gave rise to electrical engineering, now biology is giving rise to bioengineering, especially at Dartmouth. And we're moving from what they called drug discovery to actually engineering drugs. Modern medical research, as you know better than most here in Hanover, requires as many engineers as biologists and doctors. And I would also suggest leavening in a few entrepreneurs. But let's remember that 30 years were added to the human lifespan in the last century, the 20th century, but only 5 of those 30 years were added by advances in medicine. The other 25 years were added by what's called public health. And so let's be sure to do some engineering of public health, and I'd recommend that we start with obesity. I should talk. The thing about obesity is it is now threatening to reverse the trend that we've had of increasing life expectancy. So we need to get on that public health challenge. An ounce of prevention is worth a pound of cure. Challenge number 9, reverse engineering the brain. We have 3 reasons to do that. One is for fixing the many brains that are broken. The other is developing ways to make our computers better by mimicking the brain. And third is enhancing our brains so we can think superhumanly. I'm waiting for my Google implant. This is going to be fun because we're going to discover what it's like to be human, exactly what it's like to be human. And I expect that we're going to, this very century, we're going to move from carbon-based to silicon-based life forms, or the other way around. We're going to move from silicon-based to carbon-based. I can't wait to find out what you all come up with. Challenge number 10, health informatics. The internet has disrupted a series of industries. You know the list. The postal service, telegraphy, telephony, TV, books, music, shopping, photography, advertising, politics, newspapers, journalism, and dating. Such disruption is a good thing, by the way, unless it's happening to you. And 3 of the next big industries ripe for disruption are energy, education, to which I'll return, and healthcare. I think we need to figure out how to get healthcare onto the internet. Grand challenges number 11 and 12. Securing cyberspace and deterring nuclear terror. I guess I'm not an expert in those, but I can say that maybe we engineers have to remember to go back and clean up the messes we make, and perhaps we need to do a better job, without becoming Luddites, of anticipating and mitigating the messes in advance. Number 13, enhancing virtual reality. I'm not sure why the 18 geniuses put this on their list. I would rather we enhance real reality. But this leads to my prediction about the next gadget that we're all going to be wearing in various designer colors. And I wore a pair a week before last in San Francisco, and I'm going to dub them for the moment. I'm going to call them eyeglasses. So seeing through internet-enabled eyeglasses, we could go into HD virtual reality if we wanted, but I think we'll enjoy enhanced reality, like we can be able to see at night and get timely reminders of names at parties. To me, the question is, what will be the killer app of eyeglasses? What will it be? We'll find out in the next few years. And last, the 14th grand challenge is personalized learning. So education is next up on the list of grand disruptions by the internet. And I'm reminded of the Stanford professor who recently put his artificial intelligence course up on the internet and got 100,000 people to register for the course, and then 20,000 of them earned certificates of completion. This professor quickly then left Stanford to join a startup that will soon offer all of computer science to the whole world through some variation of internet education. At my alma mater, MIT, a professor there put circuits and signals up on the internet, his course. Immediately, when I say immediately, within 2 weeks, 100,000 people had registered for that course. So now MIT has joined with Harvard in a $30 million a year effort called edX to try to figure out what to do with this enormous disruption and opportunity of online education. And I suppose they're going to have to figure out some sort of sustainable business model. So there's a lot of engineering ahead on that project. Does anyone remember Polaroid and Kodak? So let this be a warning to our schools, colleges, and universities. Polaroid and Kodak could not see that their cameras would soon be replaced by interconnected mobile telephones and the internet. And they are bankrupt now. So could this happen to MIT? Harvard, probably. But certainly not to Dartmouth. All right, so those are the National Academy's 14 grand challenges, and I think you will agree, that's going to be pretty exciting to take on some of those challenges, and I can't wait to get to them. And of course, we'll be modifying the list because there's the next 50 years, but you young immortals have to worry about the 50 years after that, and then the 50 years after that. So we have to keep the list dynamic, so I'd like to add a grand challenge. And this grand challenge I'll put under the rubric asteroids. Although they were certainly before my time, some of you may remember dinosaurs. 65 million years ago, an asteroid randomly wiped out the dinosaurs. More recently, May 28th and May 29th, two previously unknown asteroids zipped between Earth and the Moon, traveling at 20,000 kilometers per something. It doesn't matter whether it was... NASA knows about thousands of asteroids large enough and close enough to threaten life on Earth. I'm worried about the million asteroids that they don't know about. If global warming has you worried, then asteroids should scare the hell out of you. Or asteroids should look like the funnest engineering challenge not here on Earth. So I think we should, as grand challenge number 14 is learn to detect and deflect asteroids using space robots, probably. Who wouldn't want to work on that? In fact, there's a new company called, Planetary Resources in Seattle. It's just been formed. They're not content to detect and deflect. They want to capture and mine asteroids. And some of these asteroids are estimated to be worth, just one asteroid, to be worth over $1 trillion in rare metals. So I urge you, don't jump up right now and run off to Seattle. They are hiring, I might add. But don't jump up now because you still have yet to get your degrees and you have yet to sufficiently thank your family and friends here. But after that, after all of that, I urge you enthusiastically to commence your engineering careers. Thank you.
Thank you, Dr. Metcalf, for your inspiring and provocative words and for another prediction, which we will watch closely to see whether or not it comes to fruition. I would now like to announce the conferring of hoods and caps on our degree candidates. Professor Ian Baker will read the names of the graduating students. As your name is called, please come up to the stage, where you will be, as appropriate, hooded or capped, then proceed across the stage and exit by the stairs on my left. Professor Baker?
For the degree of Bachelor of Engineering, Alden Claire Adolph. Amin Abu Zaid. Peter W. Ankeny. Samuel Peter Axelrod. Joshua M. Berry. Alicia Beth Belisle. Kristen Cameron Bilger. Ryan Che Virtue. Alicia Page Bone. Noah Byron Bonheim. Nathaniel M. Blakely. Amber M. Bryant. Natalie Burkhardt. Irina Kazan. Andrew C. Ceballos. Elizabeth Catherine Chang. Amanda Lee Christian. Zachary Martin Courier. Harold S. Dansu. Connor Clark Galligan. David Harrison Goldberg. Molly Elisa Greer. William Hodgson Hart. Ariana Heiderer. Lauren B. Hendricks. Donald Batisera Hondongwa. Peter Joseph Hughes. Samuel Zin Yu Hoi. Lucas Kilpatrick Hussey. Yahya Mohammed Ahmed Halim Imam. Merritt Jonathan Jenkins. Stephen Jin. Michael Oliver Stearns Johnson. John Graham Keggy. Matthew Flannery Knight. Emily Kiker Snowman. Thomas Yamato Lane. Alexis Lee Levine. Evan Omer Lipinski. Alejandro Luperon. Kelly Elise Mallory. Emily Mason Osan. Michael McIntyre McLaury. Kevin Andrew McGregor. Rochelle Morris. Amira Moratti. Jordan Roosevelt Nesmith. Christopher Eng. Roja Nuna. Olga Gasnega, Eric Ogban. Eric Packer. Christopher Michael Rowe. Paul Roby Russell. Tim M. Vanderet. Aravind Vishwanathan. Jian Wang. Peter Richard Williams. Christopher M. Zarbog. Wahid Ahmed Zarif. For the degree of Master of Engineering Management, Alison Joan McKendry. Shailesh Dominique Arana. Prabjeet Singh Atal. Sorga Bunsal. Sharnish Ashley Balboa. Ashwin Krishna Bhaskaran. Matthew Joseph Cohen. Mohit Darga. Craig Jude D'Souza. Gaurang Vijay Desai. Bochao Du. Jonathan Philip Fish. Shika Gulati. Jilin Wang. Rishank Judial. Raul Kakuel. Sarah Elizabeth Kokinos. Shongpin Quay. Kelvin K-Fung Leung. Jincheng Li. Abhijit Kedarnath Maharana. Ratish Marley. Andrea Lee Marin. Mario Jose Martinez Veloz. Laura Marie McPartland. Ankit Mehta. Bhavna Malakote Shishodri. Jens Martin Mobius. Ross Eugene Nierberg. Remya Pujita Peñala. James Tate Preston. Shaguna Poonj. Harinarayanan Ranganathan. Kunran Patik Shah. Pratik Umas Shah. Ijo Shen. Shiwatsan Sivanandan. Anirudh Sri Raman. Anshika Srivastava. Matthew Boyd Strand. Arjun Thampan Subramanian. Chien Yang. For the degree of Master of Science, Dermot James McHugh. Garrett Rogers Rayner. Lois Anissa St. Bryce. For the degree of Doctor of Philosophy, Alex Bijamov. Xiao Yao Fan. Kimberly Jean Fink. Andrew James Giustini. Amir Hossein Golnavi. Robert B. Haynor. John William Lamper. Ashley Marie Lockney. Yuchin Wan. Binzang Zhang.
Please join me in congratulating all of our graduates. Before we conclude this morning, I have a few announcements that I need to make that concern our exit from the auditorium and activities that happen immediately afterwards. First, a professional class photograph will be taken immediately after the ceremony in Moore Theater. Graduates and faculty will recess to Moore Theater via the scenery shop. There will be guides to make sure we don't get lost along the way. And the order for pictures will first be the entire group of faculty and graduating students, and then the MEM class taking a photograph. To parents and family members and friends in the audience, the Thayer School will post downloadable, high-quality, high-resolution photos online on the photo sharing site Flickr as soon as possible. What does as soon as possible mean? It means soon. Please give us a few days. You'll find the URL, the link to the website, at the bottom of your program. I would also, immediately after photographs, like to invite all of you, family, faculty, staff, friends, guests, and of course graduates, to a reception in honor of our graduating students in the tent immediately outside the front of the Thayer School, and the reception will begin immediately after the photo session. The reception includes lunch. Graduates, this may be the last opportunity for free food from the Thayer School, at least in a student capacity. For commencement tomorrow, the faculty will meet at the Hopkins Center, and students will meet in front of Wentworth Hall, both no later than 9 o'clock a.m. AB and BE students, and this is only for those of you, those 18 of you who are earning both the AB and the BE this year, you should instead report to Lead Arena no later than 8:45 a.m. So BE only, Wentworth Hall 9 a.m., AB, BE jointly, Lead Arena 8:45 a.m. Now, let me just conclude by offering a few observations from where I sit as I watch this group of students learn, develop, and evolve as they go through their program for the past 1, 2, 3, 4, 5. I'll stop counting because for some of you it's been longer than that, but several years here. A few weeks ago, I was in town at a social function, and I was having a conversation with acquaintance of mine, and he's not a Dartmouth alum, but he's someone who works with engineers. He even hires a few engineers from time to time. And I asked him about the engineers he was working with, and he immediately sighed in some frustration and said, you know, some of them, engineers don't always listen to the client. They just come in, they think they know what needs to be done, and they want to jump in and come up with a complicated technical solution from the get-go. And then he paused and he looked at me, and I think he realized who he was talking to, and he said, but you know, he said, actually, in truth, Dartmouth engineers are different. Your engineers are different. Engineers educated in a liberal arts context are different. And his point was something that the faculty and staff gathered here today know very well about you. You ask provocative questions. You listen. Your parents may not think so, but we think so. You listen. You understand context. You know how to identify the resources at your disposal and come up with creative technical solutions. You draw upon all of your education, your liberal arts background, and your interdisciplinary engineering education in formulating a response. You know how to think. You also know how to work hard to get the job done. And to illustrate the point, I'd like to give you a few numbers, and this is perhaps the last set of data you will receive from an engineering professor before you graduate. The national average for time spent working outside the classroom for engineering students is 19 hours. That's per week, not per day. 19 hours. Now, that's funny. A few of you chuckled because for many of you, I think it is, in fact, that many hours per day. And in fact, we measure this as part of a national survey each year that we conduct of our BE program graduates. And we found that year after year, our BE students are working more than 2 to 3 times as many hours on their design projects and coursework as the national average. 2 to 3 times as much. Now, perhaps that means you're just incredibly inefficient. But I don't think so, because I've spoken to the faculty who are teaching these classes. I've wandered through the project labs late at night, and I see the outcomes of your work. I see the projects, just a small subset of which we've heard about in the presentation of the awards today. And you are doing absolutely incredible and transformative things. And from the lights I see burning in Murdo and in the graduate research labs late at night, it is not just the BE students, it is not just the Couch Projects lab that's busy round the clock. Now, I tell you this and make a point in commenting on your work ethic, first, so you can turn around at the end of the ceremony and say to your parents, see, I wasn't making it up. I really was working that hard when I wasn't returning your phone calls or answering your text. I was in the lab. But I also tell you this because I know you understand that absolutely nothing worthwhile comes easy. And it's your incredible dedication to the task, to your education, and to using your education to making a difference in the world that's made your success possible. This is why more than 25% of our graduating BE students this year have filed for patent protection on their capstone design projects from this past year alone. That's a quarter of you developing something that's patentable in just a 2-term capstone course sequence. That is absolutely incredible. This is how you managed to travel to Rwanda, Tanzania, India, Haiti, observing surgeries, learning firsthand the importance of sustainable technology, and appreciating the complexities of economic development in the developing world where infrastructure is very, very different, without missing a beat in the classroom, in the design laboratory, in the research laboratory. You work hard, you ask questions, you observe, you listen, you think. This is how our MEM students found a way to take engineering and business classes at the same time, start companies, run the Thayer Gear Store, and get involved in countless other aspects of Thayer life. This is how you explore new discovery, engineer new technologies, become MS and PhD recipients who push the frontiers of knowledge and develop solutions to the incredibly challenging problems in energy, in healthcare, in communications, and maybe someday even in the mining of asteroids that Dr. Metcalf described so eloquently earlier this morning. Before we conclude, let me tell you just one other short story that really struck me, and it's something that happened earlier this week. Earlier this week, most of our graduating students, gathered with our faculty and staff at my home for a barbecue to celebrate this upcoming commencement. Now, each year, for parents and friends in the audience, each year the graduating students usually have a little exercise where they gently poke fun at one another with some mock awards, who slept the most on a couch in the atrium, things like this. And every once in a while they have some awards that poke gentle fun at some of the members of the faculty. It's a very pleasant evening and nice to get everyone together away from the school just before commencement. This year, instead, the students decided to do something a little bit different. And individual students offered their reflections on what they valued most about their time at the Thayer School, whether it was 15 months for MEM students or 5, 6, and beyond years for our ABB, MS, MEM, PhD students who came close to making a career of their education here and for whom we appreciate your dedication. Those reflections that I later learned are going to be collected in a notebook that will reside in my office for visitors and for prospective students to see, commented over and over again from students in every degree program that the common denominator was the value you derived from being part of the Thayer community, part of a community of innovators. And these were your words. Think about that. The two words that you chose to define your experience were community and innovation, about being part of a group of people dedicated to using your talents and using technology to improve the world. To your families and friends, on behalf of the faculty and staff, let me simply say thank you for lending us an extraordinary group of talented individuals for these past 2 years, for this far too short period of time. And to you, our students, let me say I'm encouraged and very optimistic about our future being in your hands. I know that you're going to carry that spirit of innovation, of inquisitive problem solving, of listening, of thinking, of understanding context before you dive in with a technological solution, the sense of community and the determination to use your education to push the boundaries of knowledge in a way to make a difference in the world. This is exactly what the world needs. Thank you for everything you have contributed to the Thayer School of Engineering and to Dartmouth College during your time here, and congratulations. This concludes the investiture ceremony. The platform group, followed by the faculty and then graduates, will now recess to more theater for photographs and then soon collect outside for the walk over the Cummings Hall and the celebratory picnic. Congratulations and best of luck.